exchanging your views on how our two industry will collaborate and increase the productivity and the safety of our products. So thank you very much, and don't go anywhere because our last speaker will be John, who's going to be doing the wrap up for the last 10 minutes of the present. So John, up to you. You're a professor at McGill, so I'm very curious to hear what you have to say about the way our two industry will join.
Thank you very much. Just before I start, a shout out to any McGill grads in the room? A few? Okay, great. So what AI means in aerospace is really a function of changing fundamentally the way we work and how we design, how we manage the manufacturing process, and of course, how we operate our equipment. And one of the things that really is kind of bothering people these days when we talk about the issue of AI is really, will AI replace the human in the way in which we design and build and manage airplanes? And I'm glad to report that that will not take place. The human being will always have a place, a very important place, in how we in fact look at aerospace manufacturing. So I'm going to just give you a few highlights in terms of what it is that we see in the research side in terms of understanding the evolution of AI and how AI is going to be, yes, transforming the business, but not necessarily replacing. It will be a complementary process to both design and engineering, and we'll talk a bit about that in a minute. But what we're trying to look at in terms of aviation and aerospace is really create smart airplanes, looking at smart design, looking at smart components, components that really will in fact provide you with information about the state of that component and where it is that that component might need some assistance, might need some replacement, and be able to predict when that component will in fact need replacement and need adjustment. So that is the intention of what transformation in the business of aerospace manufacturing is all about, trying to create something different that is really self-reporting and any issues you have in it. But the one underlying element about AI is data. And we talked about it this morning in terms of the number of issues associated with data gathering and understanding how data works. AI doesn't work without data. We need data, we need lots of data, we need lots of historical data, we need data about real-time experiences that our components and our aircraft and our people are going through. So if you have data, you have the foothold to move forward in AI. Without data and good data and quality data, AI does have some issues to deal with. But just to give you some ideas in terms of what's been going on today and how it's going to leverage itself into the future, one of the things that's really evolving is something called neural manufacturing supply networks. And neural manufacturing reminds me of the days when I had to go back to the Santa Fe Institute down in New Mexico and understand thinking about neural bots and neural networks. But it really is a way in which we can in fact look at changing the way we think about managing manufacturing.
It's not me, this.
So what? Oh. Much better, thank you. So when you talk about designing and designing everything, we talk about generative design. And generative design is a way in which we can in fact change the way we do business and using AI as an integral part of the design process. If you use AI, AI does not have a preconceived notion of what a good aircraft design should look like. It doesn't have a preconceived notion of what an engine should look like, because it says what we want to do is optimize and get the best design possible. So the airplanes of the future, the engines of the future, may not look anything like what you have today because AI is involved in really looking at a lot of complexity that is beyond the human mind, and really applying new technologies, new practices, new processes, and new design parameters to build and design new airplanes and new power plants. So it will not necessarily follow the same pattern as we've had because we've all been engineers, we've all gone through engineering school. We have a notion of what historically these things should look like. AI will change that. One of the other issues that we have in terms of how we in fact look at AI is really robots. And we're all saying, well, let's bring some more robots into this process and look at trying to standardize and get quality into the work that we're doing. And we'll get it by robots because robots do everything the same way every time.
And the one issue that we've had, and I had a conversation with Mr. Murray this morning, he says we need volume. We need a lot more airplanes to be built in order to make the economics of robotics work. And the notion would be that we don't necessarily need robots to do what they've done in the past, which is what I call scripted robots. They stay in one location, they drill holes, they do laser welding, they do cleaning. We don't need those anymore. We've got lots of those around that are stationary. We need adaptive robots. And by adaptive robots, meaning robots that can roam the machine floor, that can do different components, that can do different tasks on different airplanes. And they are adaptive and they sense the environment that they're in. So that's where we're going in the world of robotics and to how to change the way in which we look at a manufacturing plant. We need basically people to make this thing work. Yes, I'm very happy to say that McGill, that we are in fact looking at bringing out of our university graduates individuals that will in fact be the right individuals that understand AI, that understand robotics, that understand data analytics, that can in fact be the next generation of engineers and technicians and data analysts and data science people that the industry needs. But we're not there yet. We're still starting to figure out what is it that we need. We're slowly developing our programs to make it operational. So count on us to be able to do things differently. Before I conclude, I just want to talk about a couple of initiatives that are out there that really kind of strike my fancy when it talks about the way in which AI can transform the business. So we've all heard about digital twins. And digital twins are interesting in as much as what they try to do is take a physical process, a physical asset, and replicate it in the digital world so that we as designers, as operators, are able to really understand, how would this thing work with different stimulus that we apply to this digital twin, to this physical asset. So we don't have to actually have a situation that's physically represented, we do it digitally. And that is really the next generation of tools that are going to be coming out, and we're going to be using it quite a bit in our university programs to really kind of emulate and hopefully simulate cheaply, effectively, and get the design process and the release process down to a way in which we can in fact deliver technology much quicker than we can in the past. So we're using it to design quicker, build quicker, and build it more efficiently. So we're moving away from a design, build, test environment, which is what we've always had in the past. We're going to go model, we're going to analyze, and we're going to build. And that's the paradigm shift that we're working on in terms of trying to make sure that we deliver people who can understand that model and are able to deliver to that. The one thing about the industry, it is still certificated. We still require regulatory approval to everything that we do. And that's a good thing. We need that. We need that oversight. We need to have the ability to make sure that we deliver safe air transportation. And we have a ways to go to get the regulators to understand AI and how AI works and the degree to which we are using AI in our manufacturing process. So to me, that's the biggest challenge that we have, is really trying to figure out how do we in fact look at getting the regulatory bodies to come along with us and understand the value of a digital twin, understand the value of a neural manufacturing network, and to make sure that they in fact come along with us as designers and builders, come along with us for the ride, and that they're able to certify the activities. Today, there's a lot of misconceptions about AI. The regulatory bodies still don't trust it. With good reason. We really haven't taken them along for the ride. So that's our biggest challenge, and hopefully we'll be able to get where we want to be in the short term. That's about it for the future in terms of my last parting thought about where we've been. So I'm a Trekkie from way back, and I really try to understand where we are going to go with how we work. The fully autonomous assembly line is coming. May not be in my lifetime. Hopefully it'll be in some of yours. But it is something that we basically will have to, in fact, understand. We will, in fact, be designing very strange airplanes and very strange engines in the future. Thank you.
Thank you.